1, 2, 3, 4 and 5 are the 5 digits given to us. And we have been asked this. How many 5-digit numbers can be formed using these 5 digits? And we need to figure this out for 2 cases. When repetition is not allowed and when repetition is allowed. If you haven't already, I strongly recommend that you go through our previous sessions based on forming numbers. It will help you understand this session much better. Okay, let's understand what's been asked. In the first case, we have been asked to find the number of ways in which 5-digit numbers can be formed when repetition is not allowed. Okay, first things first, let's make 5 slots for the 5 digits. Is there any condition given? No, there isn't. We have been asked for all 5-digit numbers that can be formed using these 5 digits. As there is no condition, we can start from any end. Let's start with the first slot. In how many ways can the first slot be filled? We can fill it with any one of the 5 digits, correct? Yes. So there are 5 ways in which it can be filled. Either a 1 or a 2 or a 3 or a 4 or a 5. Now assume we have filled up the first slot with one of these digits. With the first slot being filled, in how many ways can the second slot be filled? As one digit is used here, 4 remain. The second slot can be filled in 4 ways. If the first slot is filled with a 4, then the second one can be filled with 1, 2, 3 or 5. If the first slot is filled with a 2, then the second one can be filled with a 1, 3, 4 or a 5. Now as 2 digits have been used in the first 2 slots, the third one can be filled in 3 ways. Similarly, the fourth one in 2 ways and the last one is just 1 way. Do we multiply these or do we add them? Don't forget the basic rules of counting. OR is addition and is multiplication. As we are filling the first and the second and the third slots and so on, we will be multiplying these. 5 times 4 is 20, 20 times 3 is 60, and 60 times 2 is 120. There are 120 5-digit numbers that can be formed using these 5 digits, provided repetition is not allowed. This is actually 5 factorial. Many students memorize this. 5 distinct things can be arranged in 5 factorial ways. Don't make that mistake. Yes, you may use 5 factorial directly, provided you understand why we use the factorial. Here, we saw it step by step. Why 5, why 4, and why we multiplied them. Don't memorize the factorial formula. Understand the logic behind it and then use it. Now let's move on to the second part. 5-digit numbers when repetition of digits is allowed. So we are allowed to form numbers like 11111 or 52333 or 31443 where digits are repeated. How do we begin? As always, we go slot by slot. The first slot can be filled with any one of the 5 digits. It can be filled in 5 ways. Now I want you to answer the next question. Having filled the first slot with any one of the digits, in how many ways can the second slot be filled? As repetition is allowed, it doesn't matter which digit we have filled in the first slot. The second slot can be filled in 5 ways again. Why was it 4 in the previous case? Because we cannot reuse the digit that was used in the first slot. In a similar way, the third, fourth and the fifth slots can also be filled in 5 ways each. And we multiply these as we are filling the first and the second and the third slots and so on. We get the answer as 5 raised to 5 ways. We can form these many 5-digit numbers using these 5 digits, provided repetition is allowed. These problems are easy, provided you understand the logic of repetition. Let's look at one last question. In how many ways can 6 seats be allocated to 6 people? Assume that the 6 people are A, B, C, D, E and F. And imagine 6 chairs in a row where these 6 people will be seated. How will you solve this? In how many ways can these 6 people be seated on these 6 chairs? Pause the video and try solving it. Think logically. Isn't this the same as having 6 different digits and being asked how many 6-digit numbers can be formed? Of course, without repetition. 6 different people are analogous to 6 different digits. Each number formed will be analogous to each arrangement formed. And it is obviously without repetition, as one person cannot be seated on 2 or more seats. If one person is seated on chair 1, he cannot be seated on chair 2 as well, right? And what will the answer be? Let's go back to the previous page. 5 digits in 5 slots when repetition is not allowed is this case. 5 factorial? Going back to the current problem, the answer to it will be 6 factorial. 6 people can be arranged on 6 seats in 6 factorial ways. Here, we have assumed that the seats are in a row. The answer will be different if the seats are arranged in a circular fashion. Don't worry about it for now. We have covered circular arrangements in another session.